All right, so today we're going to practice just taking derivatives. And I'm going to start with a bunch of functions. We're going to go through a bunch. If you want to pause and try them, this is a practice video. Try to go pretty quick. But we have f of x equals x to the 7th, and I want to find f prime, the derivative of this. And this would be an easy one for us because we have a rule. And the rule is simply this. We bring the power down. So this becomes, and to do it in 2 steps, 7 comes down, and we reduce the power by 1. Well, that's obviously 6. So the answer to the derivative here is 7x to the 6th. All right? So now that rule represents this. So then if I pull out another problem, a different f of x, but another thing, we have this. We also have another rule, all right, that we know that the derivative of a constant is 0. And if you were to graph square root of 17, which is about 4 point something, that would just be a horizontal line. Well, what's the slope of that horizontal line, tangent line, at that point? Well, it's also 0. So the answer to this problem is simply f prime of x equals 0. So we have this ability here to do these types of problems. So now we have 2 rules. Okay, that's great, right? We move our other rule up here and make it a little smaller. Let's try it on something else. I pull out the next function. F of x equals negative 4x to the 8th. Uh-oh, that doesn't look like the red rule. It's not a constant because it has x to the 8th. But we also know from our limit laws that when we have a constant buried in side with the derivative, we can simply move it out. So really that allows us to just ignore the negative 4 initially and just take the derivative of x to the 8th, which, using this rule here, is simply 8x to the 7th. So we can quickly do this, and typically we don't even think twice about how to do this. We will just actually make this quite a bit smaller and bring it up here by the red rule. And so I take capital F prime for derivative of x equals 8 times negative 4 is negative 32, reduce the power by 1. And it doesn't matter if it's a polynomial of length either. So if I have g of x equals x to the 7th, 3x to the 7th, I can simply do this probably about as fast as I can write it now. 7 times 3 is 21. Reduce the power by 1, 6. So it's times 7 minus 1. Here it's times 5 minus 1, so it's minus 10, x to the 4th. And then we get to the plus 9. Remember, what's the derivative of a constant? The derivative of a constant is simply 0. So the answer is 21x6 minus 10x to the 4th. Next one. Again, it doesn't matter if the coefficient's fractional. C is C, so half's half. So again, we're going to do this pretty quick. If you want to pause as they come out, go ahead. 4 times half is 2. Reduce the power by 1. 3 times 2 is negative 2 is negative 6. Reduce the power by 1. All right, power here is 1, right? So the 1 comes down. 1 minus 1 is t to the 0, but t to the 0 is 1. 1 times 1 is 1. And there is f prime of t. And again, it all matters. Changing the variable on the inside really doesn't change how we do derivatives. Last one on this page. And again, if we can make it fractional, it doesn't even matter. We don't care what n is. So we ignore the 4. Negative 3/4 times 4. So if I write this out, maybe to make sure students understand. And I won't do this very many times, that's for sure. Well, this is obviously just r prime of t is simply negative 3 t to the, now we leave fractional x, negative 3/4 minus 1 is negative 7/4. So as quickly as we can go, we can do these types of problems. These are some simple ones. The next video shows some more complicated ones.